For the longest time, we all thought of hardening of the arteries, atherosclerosis, as this grim one-way street. It was this slow, inevitable creep where your arteries just clog up over time, eventually leading to things like heart attacks and strokes. The thinking was, well, the damage is done. The best we can do is just try to slow it down.
Okay, so take a look at this. What you're seeing right here is the inside of an artery. And that big, yellowish bulge, that is an atherosclerotic plaque. It's this dangerous mix of cholesterol, dead cells, and all kinds of inflammatory gunk that basically narrows the highway for your blood flow. And for years, the medical world saw this as pretty much a permanent fixture.
But what if it wasn't? What if that one-way street actually had a U-turn? I mean, is the damage really permanent? That is the big question we're going to dig into. Because the science, it turns out, has a surprising and, frankly, an incredibly hopeful answer. So first, let's just really lock in on that old way of thinking. For a very, very long time, the outlook on atherosclerosis was, well, it was pretty bleak. It was seen as this chronic, progressive disease that you could maybe manage, but you definitely couldn't reverse. The classic story kind of goes like this. Lipids, especially that bad cholesterol, start to build up in your artery walls. This kicks off inflammation, which then leads to a plaque. And that plaque just grows and grows, the artery gets narrower, and eventually, boom, it can block off completely or rupture, causing a catastrophic event. It was seen as this relentless downhill slide with absolutely no reverse gear. But then, the science started to paint a very, very different picture. Bit by bit, researchers started to figure out that this supposedly unstoppable process could, in fact, be turned around. That one-way street? Yeah. It wasn't one way after all. You can actually see how the evidence just built up over decades. It all started back in the 50s with some rabbits. Scientists found if you just changed their diet and lowered their cholesterol, these plaques would actually shrink. Fast forward to the 60s, we saw the first hints of this in humans. Then the 90s hit, and the statin revolution gave us definitive proof. And now, today, with these incredible imaging technologies, we can literally watch the plaques get smaller and less dangerous right before our eyes. And all the modern clinical data has made the connection crystal clear. This quote from researchers at NYU School of Medicine really says it all. It's not just about lowering your bad LDL cholesterol. The real secret is how low you can get it. There's this direct, powerful relationship. The lower the LDL, the more your arteries can actually heal. So what is that magic number we're aiming for? Well, take a look. For a long time, the guidelines aimed for somewhere around 100, but study after study now shows that to really kickstart plaque regression, you need to push LDL levels way down, well below 70. And honestly, the most dramatic results, they come from getting LDL even lower, sometimes even below 40, which leads to these really profound improvements in artery health. It's a total game changer. Okay, so we know it can be reversed, but how? How does it actually work? Let's dive into the battle plan and look at the internal fight the body wages to heal itself. Think of this diagram as our battlefield map. That top loop, the one in yellow and red, that's the vicious cycle of high cholesterol. Lipids get into the artery wall, they attract these inflammatory immune cells, and together they build up the plaque. But the bottom loop, in gray and blue, that's the virtuous cycle. When cholesterol is low, it triggers a completely different response. Lipids start leaving the plaque, and reparative immune cells show up to clean up the mess. So to make that healing loop happen, the body has to pull off a three-part strategy. First, it's got to change who the first responders are. Then it needs a way to physically haul out all that gunk, all that cholesterol. And finally, it has to actually repair and reinforce the artery wall itself. Let's start with that cleanup crew. The key players here are immune cells called macrophages. Now, in a high cholesterol environment, you mostly get what are called M1 macrophages. Think of these guys as a reckless demolition crew. They just cause more inflammation, they gorge themselves on lipids, and they turn into these bloating foam cells that make the plaque bigger and way more unstable. But when you lower cholesterol, the body starts sending in the M2 macrophages. This is the repair crew. They're anti-inflammatory, and their whole job is to clean up the disaster zone. And this M2 repair crew, they have a special skill. It's a process called atherosclerosis. It's basically the body's super efficient garbage collection system for dead and dying cells. By going in and eating up all this debris, these M2 macrophages shrink the most dangerous part of the plaque, that soft, unstable core that's so prone to rupturing and causing a heart attack. It's absolutely crucial. So the cleanup crew has pacified the site, they've bagged up all the trash, but you still have to get all that cholesterol out of the artery wall and, out of the body for good. And for that, you need a fleet of molecular garbage trucks. And this is what that whole process looks like up close, down at the cellular level. It's called reverse cholesterol transport, or more specifically, cholesterol efflux. You're literally seeing the mechanism that lets those bloated foam cells pump the cholesterol they've stored back out into the bloodstream so it can be hauled away.
It's really a three-step process. First, enzymes inside that foam cell have to unpack the stored cholesterol. Then, you've got these special transporter proteins that act like a loading dock, moving the cholesterol to the cell's surface. And finally, HDL particles. Yep, the good cholesterol. They're the garbage trucks. They pull up, they pick up the cholesterol, and they haul it all the way back to the liver, where it gets disposed of for good.
Okay, so we've calmed down the inflammation and we've removed the cholesterol. The final step in this whole battle plan is all about structural repair. We've got a reinforced artery wall to make that plaque smaller, more stable, and just a whole lot less likely to cause any trouble down the road. And this final step involves these amazing cells called vascular smooth muscle cells, or VSMCs. Now, I know this diagram looks a little complicated, but the story is actually really simple. These cells can either be part of the problem or they can be part of the solution. In a sick artery, they get bad signals and start acting up, actually weakening the artery. But in a healing environment, one with low cholesterol, they get signals to do their real job, acting like masons, rebuilding the artery wall and creating this strong, stable cap over the plaque, which basically seals it off from causing harm. So when you put it all together, you've got the cleanup crews, the garbage trucks, and the structural repair team. The conclusion is just revolutionary. We've gone from a disease that we thought was unstoppable to one we now know we can actively reverse. And understanding how it's reversed, well, that changes everything about how we look to the future. So let's just quickly recap that battle plan. First, and this is the most important thing, atherosclerosis is not a one-way street. It is reversible. The number one driver of that reversal is getting your LDL cholesterol down to very low levels. And this whole U-turn process involves switching your immune cells to a repair crew, firing up the body's cholesterol garbage trucks, and reinforcing the actual structure of the artery wall. It's not just slowing the disease down, it's a real active healing process. And that leaves us with this truly exciting question for the future. We've proven that regression is possible. So the next frontier has to be figuring out how to make it happen more effectively for more people. As our understanding of these repair mechanisms grows, could we develop therapies that don't just prevent heart disease, but actively heal our arteries? Could we actually make heart attacks a rare event, a thing of the past? Based on the science we're seeing now, that future feels closer than ever before.